Hi, this is Arjun. This is the second part to the tutorial to stream and process Twitter data. In the first part, we looked at how to set up a streamer using Tweepy and stream and save tweets as a tab separated file. Here are the two files. D1 is without the query and D2 is with the query. And this is what the file looks like. So I have the tweet ID and the tweet text. Um, so in my file, I extracted only the ID and the text, but you could extract all the information. And right now I'm using tab separated uh, format, but you could save them as a JSON or any other format that works well for you. And we can process. So I'll run through a quick tutorial using a Python notebook to show the steps to process this data. So these are the libraries that I'm importing. I'm using pandas, regular expression, matplotlib, and collections. Matplotlib is to create like the word cloud plot, and collections is one of the tools that I'm using to one method that I'm using to generate word frequencies. But you could do this with NLTK or with Spacey as well. I'm just showing all three methods here. NLTK has several tools like stopwords and tokenizer and things like that you could use. Spacey also has tools. So I'll give a brief introduction and show how to use these libraries to process your Twitter data. So the first step is to load the data. Okay, I just need to run this. Um, yeah, so the first step is to load the data. So I've defined a set of functions that I'm using to clean my tweet and do the processing. We'll go into each of those functions in detail. So as I mentioned, the first step is to load the data. So this is what it looks like. So the reason I'm using pandas, it's quick and easy to view and show how the tweets are being processed. But you could use any library or any other package that you think will work well for you. So you see, I have the tweet ID and the tweet text. So once I load the data, I'm removing the special characters. So I don't need all the tweets will have web pages, HTTPS, and other special characters that are not required for the word count. So I'm setting up like a regular expression to remove these special characters and like web pages. That's that here. So if you see this example here, for example, the web page has been removed. The special characters have been removed, which includes the at symbol and things. So you could set up like an expression to remove special characters and web pages, so you get the tweet text. The next thing I'm doing is I'm removing the other language characters. So my goal is to right now I'm going to show a simple word cloud, and I'm going to remove the other language characters. But if your analysis requires other languages, then you could keep it on. So the way I'm doing this is I'm using a language detection library to remove the other characters, other languages. So here's a quick step on how it works. It takes some time because the language it checks and gives a code for each of the languages, and I'm filtering out anything that's not English. And you see the other languages have been taken out. Like for example, here in my index, you see 0, 1, 2, 3, which are not in English, has clearly been removed. And similarly, other elements that are not in English have been removed. The next step I'm doing is tokenizing. So what tokenizing means is I have a sentence and I break it into tokens of words. And in this step, I'm just using split words function. Basically, what I'm doing is I'm using the spaces to split each sentence into words. One other thing is I've converted all of them to a lowercase I don't know if you noticed that, but that's something I do as well in like one of the about two steps. Um, so that's our tokenized list you see here. Um, so the sentence has been broken down into words. The next thing is I'm using. There are you could tokenize this using Spacey and NOTK as well. So I'll go down and show an example of how we tokenize using Spacey. So this is just a regular Python function that does the tokenizing. So once that's done, we now remove stop words. So the reason we remove stop words is say I don't want to count words like a preposition or is and does or uh, any other word that I want to remove, I could set it up to remove as stop words. So NLTK has a library called stop words. So you import the NLTK stop words, download the list of stop words, and I'm using a function to remove, using the NLTK stop words library to remove stop words. So if you see in this example here, the words are, is, no has been removed. Similarly, these digits have been removed, and off has been removed, I has been removed. Uh, so that's the thing. So stop words remove prepositions and yes. So you could go in detail and like pick up the NLTK stop words and read up a little on like stop words and what it does. So once I have the stop words removed, now I have my list of words in each tweet that I can find the count and I can create a bag of words model. So here are a set of functions that I'm showing that you can use to create a list of unique words. So basically what I'm doing is I'm taking this list, exploding the list, and combining the words to form a unique list. So this first step here shows how to create a unique list of words. The second is you could use collections.counter to create a count of each of the words in the list for each tweet. Oh, I could combine all the words and then create a counter as well. Normalization. So what's normalization? So this is one, I'm creating a counter using collections. I could also create a counter using the NLTK library, which NLTK frequency list is a counter that creates a count. So all these counters, they are not normalized. So for example, here I have the words check 7 times, like repeated 7 times, get repeated 7 times, new 5 times, etc. And you see the NLTK and the normalized words, the collections and the NLTK, they are identical. Um, so what normalization does is, so I take this count, and let's say I had 1,000 tweets. I divide the counts by the total number of tweets to get a normalized value. So right now, these values are not normalized, and that's why we divide by the count. So since I filtered, I'm using the number of filtered tweets that I use to create a normalized count for the frequencies. So that's like most of the processing. And once we have the word count and the word frequencies, the normalized word frequencies, I can use that to create like word clouds. And this is a simple word cloud. So for example, if you see, these are my top 10 words, and words like get, check, and like have the highest font because they have the highest frequency. So here is a simple word cloud generated from frequencies. There are like other options you could use to create a word count. And here's a quick reference that I provided that you could use to go through like the word cloud library and see all the different options that you can use to generate word clouds and compare word clouds. Um, so that's about using the NLTK and simple Python to create tokens and analyze word frequencies in your tweet and also generate a word cloud. Let me now go on to show the same thing with Spacey. Spacey is another interesting and very powerful NLP package that provides a lot of options for text analysis. Um, so here we start by importing Spacey, and the second line here is just to show this display. Import display C, and the first step in Spacey is to load the NLP module or the language model. So in this example, I'm using the small, the web small. There are three modules. There's a web small, there's a medium, and a large. The web small is simple and quick to load, and that's the reason I'm using. You could try out the medium and the large. It may or may not make a difference. For our analysis, I think the web small is pretty good. And here is a simple text. So let's start with the text. So you see this text here. The first thing is to call the NLP pipeline. So what the doc equal to NLP text does is it builds an NLP pipeline where it takes this sentence and breaks it down into different types of tokens. So we have the parts of speech token, which you see here as a pronoun, auxiliary, noun, adverb, verb, adjective, etc. So that's the parts of speech for each of these broken down tokens. It also gives the token words, and it gives the lemma for these words. Let me go in and show what the lemma is in a couple of seconds. And it also gives a lot of other options in these tokens. So how do I access these tokens? So how do I access these tokens is using this doc. So here's a simple for where I'm calling for token in doc. I am printing out the different tokens. So the first one is token dot parts of speech. So you see the pronoun, auxiliary verb, adverb, verb, adjective, etc. The second one is token.text, which is just the word itself. The third one is token.lemma. So what is token.lemma? So what lemmatization means is Spacey combines words that are similar. Like for example, coming and come are similar. It takes it as come. So if all versions of the word will be combined together. Similarly, times and time, all versions of time will be combined to time. So that's the lemma. And you also have stop words in this. So you see it tags each word as a true or false with whether it's a stop word. So for example, together is a stop word, a is a stop word, have is a stop word. And you can use this to filter out these stop words. So that's like a quick introduction to Spacey. Spacey is pretty powerful, and again, here is the link where you could go explore more of Spacey's usage and like tutorials and fun things to do with Spacey. So I hope that was helpful. And again, as I said before, do get with us if you get stuck in this process, and or if you need any, I have any questions related to the analysis. That's all I had for now, and hope that was helpful. Thank you.